Hello students, welcome to Software's classes. Today we'll be solving the CSIR UGC NET questions from the June 2018 paper. We'll be solving the set C of the Mathematical Sciences paper. Let's start off with question number 37. In 37 it has been said that let f, which goes from z where mod of z is less than 1 to c, be a non-constant analytical function. Now which of the following conditions can possibly be then satisfied by f? Option 1, f of 1 by n, which is equal to f of minus 1 by n, is equal to 1 by n square for all n which belongs to the set of natural numbers. Option 2, f of 1 by n is equal to f of minus 1 by n, and that is equal to 1 upon twice n plus 1 for all n which belongs to set of natural numbers. Option 3, mod of f of 1 by n is less than 2 to the power minus of n for all n which belongs to capital N. It is a set of natural numbers. And option 4, 1 by root pi is less than mod of f of 1 by n, which is less than 2 by root over n for all n which belongs to the set of natural numbers. Let me correct it. I said that this is 1 by root pi. This is not 1 by root pi. This is actually 1 by root n. Okay, the correction. Let me rephrase it. This is 1 by root n. So let's proceed with the question. So we have been given that f is a non-constant analytic function. So if it is a non-constant analytic function, basically it means that if it is non-constant, that means that it is not bounded. It is unbounded. Okay, so we have to check this for all these four functions that we have been given. So in the option 1, for option 1, we have been given that f of 1 by n is equal to f of minus of 1 by n, and that is equal to 1 by n square for all n which belongs to the set of natural numbers. So we can definitely define a function g of z, which is equal to, basically we can write as z square. We can, from this structure we can define a function gz which is equal to z square, and that will mean that g is analytic on z such that mod of z is less than 1. Okay, so this is the definition that we have been given. So now if we find out g of 1 by n, so g of 1 by n will be equal to n square, and g of minus of 1 by n will be also equal to 1 by n square. So we can say that f and g agree on A such that 1 by n and n belongs to the set of natural numbers. So we can say that f is congruent to g. Okay, so we can say that therefore option 1 is correct. Now let us shift our focus to option D. For option 2, in option 2 we have been given that f of 1 by n is equal to f of minus of 1 by n, and that is equal to 1 by twice n plus 1 for all n which belongs to the set of natural numbers. So now f of 1 by n is equal to 1 by twice n plus 1. So if we divide both the top and numerator and denominator by 1 by n, so this will become by n rather, this will become 1 by n upon 2 plus 1 by n. So therefore we can define a function gz which is equal to z by z plus 2, and that is analytic on, which is supposedly analytic on z such that mod of z is less than 1. So this is what we know. So now if we find out g of 1 by n, so g of 1 by n will be equal to 1 by n by 1 by n plus 2, and this will come down as 1 by twice n plus 1. Okay, for 1 by n such that n belongs to the set of natural numbers. Let us find it for g of minus 1 by n. So g of minus 1 by n will be equal to minus of 1 by n minus of 1 by n plus 2, and this will be equal to 1 by twice n minus 1 for minus of 1 by n when n belongs to the set of natural numbers. So as you can see, g of 1 by n is not equal to g of minus 1 by n. So therefore g of 1 by n is not equal to g of minus 1 by n. Let me insert another page over here. So therefore we can write, so therefore f is not congruent to g for a minus 1 by n where n belongs to the set of natural numbers. So therefore this f is not satisfying our condition, satisfying the condition. So therefore option 2 is incorrect. Now let us proceed to option 3. In option 3 it has been said that mod of f of 1 by n is less than 1 by 2 to the power n for all n which belongs to z. Okay, so this is what we have been given. So now if n tends to infinity, then that implies that mod of f of 1 by n is less than 1 by infinity, which is equal to 0. Okay, so therefore we can say if we take 1 by n is equal to z, then mod of f of z tends to 0 as n tends to infinity. Then that implies that f of z is bounded, and if f of z is bounded, that implies that f of z is constant. But we have been given that f of z is a non-constant analytic function, so therefore f of z mod of f of z less than 1 by twice n is not correct. Okay, this condition is not satisfied, and that will imply that our assumption is not true. There is a contradiction over here. There is a contradiction which is given by this portion. Since we have taken that f of z is, we have been given that f of z is not constant. So therefore option 3 is not correct. Now let's shift our focus to option 4. Similarly, we'll apply the same theorem over here, same theory over here, there as well. So we'll write, we have been given that 1 by root over n is less than mod of f of 1 by n, and that is less than 2 by root n. So we can write, if we take 1 by n as z, so 1 by root n will be less than mod of f of z, which will be less than 2 by root n. So as n tends to infinity, this will imply that 0 is less than mod of f of z, and that is less than 0. So that implies that f of z is bounded, and if f of z is bounded, that implies that f of z is constant. But it has been given that f of z is non-constant. So if f of z is non-constant, so that implies that fz, where it is given that fz is less than 2 by root n and greater than 1 by root over n, is false. So option 4 is also incorrect. So therefore the correct option is only option 1. Okay, so today we have solved a question which came in the CSIR UGC NET June 2018 paper. We'll be solving the next questions in the subsequent videos. Till then, keep watching Softsource Classes videos for more solutions and content. Thank you very much.